Okay, finishing up on day 3 where you were adding and subtracting rational expressions with like denominators. I did the first 2 examples with you in class to show what happens with unlike. Okay, so we're going to go ahead and do unlike now for day 4. Okay, starting with example 3. So these do not have like denominators. So what is going to be my common denominator? If you watch other people's videos, they're going to say the LCM or the LCD. Okay, I just want to know what's a common denominator between 4 and 5. Well, that would be 20. So that means I'm going to need to multiply the first fraction by 5 over 5. And it doesn't matter if you keep these in parentheses like I showed in class. Okay, the reason why I am now putting this in parentheses because now I have binomials. Okay, up here we didn't have binomials, so I just put what I was multiplying by in the parentheses. So here we go. The next part is 2a minus b over 5. That will need a 4 over 4. So now I have 20 as my common denominator that I keep. And now this is 5 times a plus b plus 4 times 2a minus b. It's the whole numerator. So now, if we multiply that out, it is 5a plus 5b plus 8a minus 4b all over 20, which is going to give us 13a plus b over 20. This we always look to see if we can reduce in any way by GCF or any type of factoring, and it can't, so we leave it. Okay, so now this next one. What's going to be my common denominator? Well, 3 and 5 can both go into 15, and x can go into x squared, so we can keep it x squared. So that means the 4 over 3x will need what's missing. So to get this to become 15, I need a 5. To get this to become x squared, I need an x. The 3 over 5x squared is missing a 3 to get it to become 15, and it already has the x squared. So I do not need anything else. So my common denominator is 15x squared. This is already 15x squared, so it's 15x squared. I don't ever change that. Okay, now my numerator is saying to take 5x and times it by 4, then minus 3 times 3. So that is going to give me 20x minus 9 over 15x squared. There is no GCF here. Yes, 5 can go into both of these. Yes, 3 can go into both of these, but there's not one number that can go into all 3 parts. So there's nothing we can do with that. Okay? Okay, next one. Well, this one's a little different. Sorry, the sunlight is, there we go. Okay, this one's a little different because we have binomials and trinomials. So what you need to do first is factor it. There's a GCF here. Okay, and this is a factor by IAM, the IAM factoring. So this is negative, x minus 4 and x plus 1. So what's going to be my common denominator? Well, I'm going to need a 2x because that's missing here. I have an x plus 1 in both, but this x minus 4 is missing here. So this is common, but I'm going to need this as well. Okay, so you're basically taking one of each part. So this one, this 3 over 2x x plus 1 is missing the x minus 4 plus this 5 over x plus 1 x minus 4 is missing the 2x. A lot of students find these more difficult, and I think once you factor, I think they should be a little bit easier because you can literally see what's missing. Okay, this doesn't have the x minus 4, and this doesn't have the 2x, so that's what you multiply by. Okay, so now, do you see how the denominators each have the same thing? So once they each have the same thing, you write that once. And of course, order doesn't matter in multiplication. I just always put a monomial first. And now this is saying 3 times x minus 4 plus 2x times 5. So that is really 3x minus 12 plus 10x over that same denominator. But I see these two can combine. So my final answer is 13x minus 12 over that same denominator. So 2x times x plus 1 times x minus 4. Okay, that's the same denominator that would have been here. This cannot GCF, so there's nothing I can do with that. Okay, there's your final answer. Okay, let's move on. Okay, again, this is not factored. So this is factored. There's nothing I can do with it. But this is 4 times x minus 2. So your common denominator, you need one of each part. This x minus 2 is there. It's already there, but it's missing the 4. So there's each piece. So your 5 over x minus 2 is missing the 4. And your 3x over 4 times x minus 2 isn't missing anything. It has the x minus 2 that was in the original. So you don't have to multiply that by anything. Once your denominators match, carry it over. And then this is 20 plus 3x. 20 plus 3x. Notice I did this a little bit differently. I just didn't write the whole thing out because this is simple enough to multiply in your head. This cannot factor, doesn't have a GCF. The only other thing you could have done was maybe written it in descending order if you wanted. You don't have to, and you would know if it was multiple choice if you had to or not. Okay, same thing with distributing this through. I tell you don't ever do that because you're always trying to keep it in simplest form. So if you keep it factored, you would see if it could cross cancel with another factor or reduce. Okay. All right, next one. This is this if you take out its inverse. We have talked about that multiple times. These two things are the same. Okay? So we shouldn't need to discuss that. But this negative, if you recall, I have told you that it is the same thing as putting it in front of the fraction or in the numerator. So I'm going to rewrite this. Whoops. And I'm going to put it in front of the fraction. So instead of it being in the denominator, if I put it in front of the fraction, if you notice, I now have like denominators already. And this plus minus just simply means subtraction. So now it's just 7m minus 5m is 2m over m minus 3. This is a binomial that's locked in. The m's can't cancel. That's it. That's as far as you can go. Okay? All right. C. This is a trinomial that needs to be factored. There's a 1 here, so you know you can do that IM. B squared is b times b. C squared is c times c. And now we just look. What two numbers would multiply to a positive 1 and add to this would be -1 and -1. I don't need the 1 there. okay? If you want, double check this, you do your FOIL, that's what that is factored, okay? So if you notice, it has as a common denominator, it has b minus c twice, b minus c twice or squared. This doesn't have it twice. So this one is going to need another. So this has b minus c squared minus b over b minus c needs another b minus c in order for it to be squared. So now I have b minus c squared, and my numerator is b squared minus b times b minus c. So distribute that through. B squared minus b squared when I multiply. And then when I multiply again, it becomes plus bc all over b minus c squared. This cancels, and I get bc over b minus c squared, or b minus c times b minus c. Okay? Alrighty, last one. Factor first. This is x plus 1, x minus 1. And this is x plus 2x minus 1. Again, I told you guys, if you don't know how to factor quick and easy, you need to go back and watch all those factoring videos, okay, or come for extra help. So your common denominator, I'm going to start with the first one, x plus 1, x minus 1. And now I have the x minus 1 already in this, but I don't have this, so that has to come along. That's my new common denominator, which means my first fraction of x plus 1, x minus 1's denominator needs x plus 2. Minus my next fraction of 2x over x plus 2, x minus 1 is missing the x plus 1. Okay? Now, some teachers write it in front, some write it behind. It's completely up to you. So now, my denominator has an x plus 2 in both, an x plus 1 in both, and an x minus 1 in both. So common denominator comes down. And now this is a monomial times a binomial, so I need to write that in this order. And this is minus a monomial times a binomial. And now distribute. X squared plus 2x for this. And then this is minus 2x squared minus 2x when you distribute. All over that same denominator. X plus 2, x plus 1, x minus 1. Combine what you can in your numerator. X squared minus 2x squared is a negative x squared. 2x minus 2x is gone. So that is all over x plus 2, x plus 1, and x minus 1. And nothing can reduce. The only other thing I would say is don't forget your undefined that we did way in the beginning. You don't have to do it for these, but if you did have to, or you were checking the answers anywhere, it would also mention that x could not be a positive negative 1 or a negative 2, because if it was, one of these would become a 0, and remember undefined says you cannot have a 0 in the denominator. So I just thought I'd add that to the last problem to remind you what we did on the first lesson. Okay? All right, so when you come in tomorrow, we will start working on these classwork homework type problems and get you all caught up. See ya.